Hello, in this video I will show you how to solve a simple current divider circuit using many ways. So in my case I will show you how to use current division as well as resistance simplification. So first things first, we need to remember what current division is, and this is the canonical circuit, meaning it's like the default circuit for any current division or any circuit that can use current division, which is going to be two resistors in parallel with each other and both of them in parallel with a current. And in this case, the current is going up. And if we remember KCL, whatever current comes in is the same current that goes out of the node. So in this case, the current in this branch goes like this, and thus it will go and split on R1 and R2 proportional to the values. So how much? Let's say we want to find the current flowing through R2. So the formula using the current division is the current source times the resistor you don't want to take the current from, in this case is R1, over the sum. So with that in mind, now we have here our 8 amps, which is our current source, and we can see the direction that goes up. So in this case, it goes counterclockwise, and again, by KCL, it will split like this. How much? Well, now it's time to calculate the first the current, then the voltage. So we are being asked to find the voltage here, V naught. So what I'm going to do is I'm going to use the current division formula to find I naught. So I naught equals 8 amps times, and then the resistor we don't want, which is 5 ohms, over the sum. So in this case, it's going to be 5 over 13 times 8. In this case, we get 3.077, more or less. So this is the current. And then to find the voltage is just a simple Ohm's law. So V equals IR. However, this current, because of the direction of this source, we know that the current here is going down. So in our case, the current enters the negative terminal. And by the passive sign convention, whenever the current enters a negative terminal, the power is negative, or the product of voltage times current. So we will make a negative, or we will put a negative sign in front so that we know that the polarity is reversed because of the passive sign convention. So it's going to be equal to the current, which is 3.077 times 8. So when we do that, we get minus 24.615 volts. So now we are ready to put in our answer, minus 24.615. We submit, and then we get the correct answer. So now let me just solve a similar problem, but now using resistance simplification. So in this case, remember that this resistor has a parallel connection with the 9 ohms. So in this case, notice that both of them share the same terminals, as there's only wiring between them. So then we can, if for some reason you kind of cannot visualize really what's going on here, if they're in parallel or not, you can slide this 1 ohm resistor across our resistor, which is going to be 9 ohms, and then our other resistor, which is going to be 1 ohms. So now in this case, we have the voltage going like this, and we know that the current goes down, so then it will be split up like this. And if you notice, the current will hit the negative sign. But since we're working with resistance simplification, we can simplify the resistances in parallel without compromising the value of V naught. Why is that? Because of the underlying concept, which is extremely important to understand and memorize, which is circuit elements in parallel share the same, or not share actually, let me be more clear, have the same voltage. So this is extremely important to put into consideration because this is something that will accompany you throughout your career. This is something very basic to understand. So circuit elements in parallel have the same voltage. So this means that the 9 amps, the 9 ohms, and the 1 ohm resistors have the same voltage. So we can combine them in parallel and they will have the same voltage. So then we can just combine these two in parallel. So when combining them is the product over the sum. So then it's going to be 9 times 1 over 9 plus 1, which is 9 over 10, 0.9. So we have a 0.9 ohm resistor. And notice the current here, I'm sorry, the voltage, right? And the current enters the negative terminal. So our voltage done by Ohm's law is going to be V equals minus I times R. In this case, it's going to be minus 9 times 0.9. So we get negative 8.1 volts. So this is another way by simplifying resistors in parallel. It only works with 2 resistors in parallel. So let me just put in the answer here, which is going to be negative 8.1 volts, and then we submit, and it's correct. So hopefully with this video, I've helped you understand a little bit about current division. I hope you learned from this video. Thank you for watching. If you have any questions or comments, please let me know and keep practicing.